Hey everyone, my name is Bronley Plumb. I'm one of the founders of RokuCommunity. We're best known for the BrightScript extension for VS Code, as well as BrightScript, Roku Deploy, the RokuCommunity Promises library, and several other tools. You can check out our website at RokuCommunity.github.io to learn more about our projects, as well as find some resources on how you could contribute if you're looking to help out. And we also have a newsletter. We send kind of periodic updates whenever there are large changes to the extension or other interesting things that you may be interested in. So feel free to subscribe to that. So when we're planning these presentations, there's always an interesting balance between showing new features as well as also wanting to cover some of the more common functionality to help newer Roku devs. With so many changes and updates this year, we're going to mostly focus on new functionality and bug fixes, but I will try to mix in a few tips for developers that are just getting started. You can also find all of our presentations from the past few years on Roku's YouTube channel, which I will show you right here. They've got playlists for 2021, 2022, 23, and 24, and our community tools presentations can be found in there as well. One final thing I wanted to mention is that we will be having a Q&A session at the end of this presentation. So you can scan this QR code and submit all of your questions there, and we will get through as many questions at the end of the presentation as we have time for. Today, I'd like to talk about the VS Code extension updates that we've made. We have a lot of great improvements in the tool, some quality of life things, just some nicer syntax enhancements, a few other things we'll get into. Then we're going to talk about the debugger enhancements that we've made. We've partnered with Roku and their debugger team to try and improve this experience for all developers. It's come a long way, and we've got a lot of awesome things to share there. And then finally, we wanted to showcase how to set up your Roku to be able to run unit tests and on-device automation testing using GitHub Actions self-hosted runners. So we don't have the deployment side of CI/CD, but this is still going to be a huge benefit to you and your team, and we want to show you how we can set that up. So let's talk about VS Code extension updates. The first one is a pretty common mistake that developers run into when they're using our extension. They're used to having a telnet connection open in a terminal or something, like I'm going to use the VS Code embedded terminal here. And then they try to sideload directly to the device using VS Code. So we'll pick the same device. And what would typically happen in the past is it just wouldn't show a pop-up. It wouldn't log anything. You just wouldn't know that there was already a telnet connection open. So we've improved our detection abilities here. So we now recognize that something else is connected to the Roku. And so we can stop this. We can quit our telnet connection. And then let me sideload again. And this time it should connect without any issues. And there we go. The app is running, which is great. Another problem that developers run into is there's this issue on certain Roku devices, I haven't seen it on all of them, where the device needs to regularly check for updates, but it can't for some reason. And if you haven't checked for updates on your device, I don't know the time frame is. It might be like a week or 2 weeks. If it hasn't checked in with the Roku servers, it won't let you sideload your developer, your dev apps. And so we have found a way to detect that as well. And so let me sideload here to a device that has this state. Prior to this, you just, again, wouldn't see any pop-up, wouldn't see any issues at all. But now you should get a nice notification explaining what the problem is. That you need to check for updates on that device. And we actually even give you instruction on how to do that. Navigate to the system settings, check for updates, and try again. So let's just show you how to get to that. It's going to be in your settings right here. And then you need to go to System, and then Software Update, and you need to click Check Now. It doesn't actually matter that you have updates. It just needs to have checked. So we've solved this for developers. We've made it a lot more clear why a side load is not happening. And hopefully this will make it much easier to figure out what issues are preventing you from side loading your applications. Next, let's talk about the automations panel. We've added new capabilities to load and save automations, have multiple automations, even export the entire list. So to get to automations, you would select the Run and Debug tab here on the left, and then it may be in any order here depending on how you've configured your system. I've got one called Select Third Item where it sleeps for 5 seconds and does 2 down key presses and then an OK key press. So we're going to go ahead and run that. And you can watch it as it goes as well. All right. Now, let's say I want to do another automation. I can click this menu at the top. And then I can select this button right here to duplicate it. Let's say I want to do more down. So I'll click that. And let's do Select Fourth Item instead. And I could rename this if I didn't like that by double clicking. And so let's go ahead and click on it. So now let's add another key press for down, and we can move that up. So now it's down, 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 okay. And let's launch that. And there it goes. Now what is also nice about this is you can have as many items as you want, but you can also export the entire list. So we'll click that button there. Let's save it to my desktop, automations. Now I can open that in VSCode. And we can edit this. Let's say, I want all of my sleeps to be just a little bit longer. Let's make them 8 seconds. I can save that. And just so we can see again here, this is still 5. So let's go ahead and import that same file. And there we go. They're both 8. So prior to this change, you were only ever able to have one automation. And now we have added the ability to have multiple named automations, as well as back them up, editing the JSON and importing that JSON again. So it's really powerful. Next up, let's take a look at the thumbnail in the app overlay grid. So we'll go back to VS Code here, and I will choose the Roku app overlays panel. And in order for this to work, we need to actually side load to the device. Let's go ahead and do that. And now what this is going to do is it's going to upload images to the Roku and allow you to superimpose some kind of design artwork or graphics or something to help you lay out your application. So let's just choose the Roku Safe Zone overlay for now. And let's look at what that looks like on the Roku device. As you can see, that is overlaid on our device. And I can adjust the opacity to see how that lays on our application. And what's new about this is that we actually added the thumbnails or the preview images here in VS Code for those overlays. So let's add another one, and I'll choose this overlay. And so now you can see both of the images. Prior to this, we only really had the file name. So this makes it just a little bit easier to pick which overlay you want to be testing with. Next up, we've got syntax highlighting improvements. And it's going to be easiest to show you this stuff just on GitHub. So we had a couple of bugs related to how we were highlighting m.top. I think last year sometime we started actually highlighting m.top the darker blue like M, but we had a bug where it was incorrectly capturing just the top even if there was text that came after it. So now in VS Code you can see here m.top is colored correctly, but any other instance of m.top, they properly recognize now that those are variables, not m.top. We also had another bug where the getData method, as well as a bunch of other native Roku event methods, were being colored yellow inside of associative arrays. And that is fixed now, so those will get the same color as other properties on the associative array. We fixed some bugs with BRSDoc. So you notice here in this issue, the return type was not getting colored. It was just being captured as a comment. But now we will properly highlight return or returns plural. Both of those support the type inside of curly braces. And so the integer or whatever you want to put in there, it'll color it as a type. And then another syntax highlighting issue that we had was comments inside of enum statements. If you notice here, the comment is just standard text. It's not even being captured at all. And so if we look here in VS Code, this stuff now works. And then this last one, there are a whole bunch of BrightScript objects that we did not have on our list. Some of these are actually BrightSign as opposed to BrightScript. So we went through and we looked at the documentation, compared both of them, and built a union of all of the different types. So even if you're using our VS Code extension for BrightSign development, which we don't have a ton of support for, if it works, it's just a happy accident, we can at least give you the correct syntax highlighting colors. And another nice benefit of this is that GitHub is now using our VS Code extension syntax file for BrightScript and BrightScript code blocks. So anytime you wanted to do a code block like that, that's built off of this list. I think they pull it quarterly. So that's just another benefit. But yeah, there's a whole lot of items here we had not included in the past. And so if you're a BrightSign developer, you get a lot more syntax highlighting colors for these BrightScript objects. Next, let's talk about some of the remote control changes we've made to VS Code. And similar to the syntax highlighting improvements, this is most likely easiest to explain by looking at GitHub issues. So we've added a new command called setVolume that just presses the volume down button repeatedly till we get to 0, and then volume up enough times to hit the number that you want. A couple other random ECP related button presses that we found in the wild, the exit button, as well as a press volume up button fix. That was broken. I was sending the wrong value and erroring, so now that has been fixed. So if you want to see how to use those in the editor, you would open your command palette and then you would type set volume. And there's a set volume on the Roku volume enabled device. And then you can set your value if you want to set it like 50 or whatever. And I don't have a Roku TV to test this out on, but this is how that would work. And then the other change is the page up and page down mappings on the Roku remote have been, on the keyboard mode, have been inverted. So the way you enable this is you go in here and you press Command K. If you notice at the bottom, it's now flashing red and yellow or orange. And that allows us to send different key presses. So on my keyboard, I can press up or down or left or right, and that navigates on the device. And what we noticed is that developers were constantly asking for us to swap page up and page down because of the way they interact with row lists and label lists and stuff like that. So you can check out the pull request if you're interested, but just know that we've made those changes in the last year. And so if you've noticed a change in behavior, that's why. So next I want to talk about the project discovery improvements. And before we get too deep into the changes, I want to first kind of explain what project discovery is. So here's a quick example in VS Code. We've got a small Roku app with the main file, main scene, and then also a shared file called gradient. And that file is imported inside the XML file. So the VS Code BrightScript Language extension ships with a language server. And that language server needs to understand a little bit about your project. It needs to know where your source and your components folders are. And so I can kind of prove that it's aware of that by disabling the gradient import, and all of a sudden the function from gradient.brs is no longer available inside of this file. So the language server is correctly building a map of all of your files and which ones are imported where and what functions they export, etc. So out of the box, we support finding projects a few different ways. The most simple way is we read the root of your project. And in this case, this is a simple app, no big deal. But we can also discover your projects if they're nested. So let's make a folder called app. And let's move components, source, and manifest inside of there. And I'm going to restart the language server. You notice it's working. It detects again. So the language server is working. Now let's do something else. Let's actually make another folder called app2 and another one called app3. And let's copy the code into each of those. And we're going to reload the language server again. So catch everybody up. So now we have 3 different apps. And if you'll notice, we actually get validations for any of them. So in this case, I only edited app 3, and app 3 is the one with validations. Let's go to app 2 and do the same thing. Great, so we're going to leave that one alone. We're going to leave app 2 broken, but app 1 and 3, we're going to leave them alone. So again, this is really flexible. We're able to find all of the Roku projects in your local workspace. But as you may already be thinking, well, what if I have a mono repo with 10 Roku apps in it? Or we have a very complicated structure where there are apps all over the place. This can get really expensive really quickly. And so what we have added in the latest version of the VS Code extension is a new setting to manage these. So if you go into settings.json, either here in your .VS Code folder, or you can create your own settings option in your personal settings, like in here, for example. So we're going to do BrightScript.projects. And then this is an array of projects. And so we're going to go ahead and set path, and I'm going to say app1. Okay. Now, if you notice, the errors in app2 went away because we're not validating app2 or app3 or even app. They're all gone because I typoed this. So let's go ahead and rename this to app1. And it's still okay. So let's go ahead and change the import in app1 and reload the language server. And see what happens. So path is app1. And all of a sudden we are getting validation issues. Let's go ahead and put that back. And it's back. So let's move on to change this to app2. And all of a sudden app2 is being validated on its own. We go to 3, app2 is not being validated anymore because we've disabled it. So this new projects array is a very flexible way to kind of tailor your editing experience to whichever projects you're working on. If you have a large list of clients and all of their projects are in a mono repo, this is now a way for you to manage which projects you actually want to be validating and editing. Another good use case for this is if you've got an application and a unit test project, and you don't want the unit test project running all the time because the validation takes twice as long. So you can go in here and you can change to just run the app or switch to just running the unit test project. We've made a couple other enhancements. I'm not going to show them because they're more behind the scenes, but we've improved the handling of symlinks. Previously, if you had cyclical symlinks, it would follow them forever and then the language server would crash. So we've set a max depth to that now that it will stop after a certain depth. We've added a couple other enhancements, but all in all, this project array should give you the flexibility that you need to be able to configure your projects and kind of rein back the extension from being a little too CPU hungry. And next up, I want to talk about some of the language server enhancements that we've made. As I mentioned earlier, the language server powers all of your in-editor experiences in VS Code, like completions and hovers, etc. And back in February, we merged a pull request that rewrote a significant amount of the language server. If you can tell here, there's many thousands of lines of changed code. So I want to show you this in action. Now, the language server is powered by the BrightScript project, and that doesn't mean you have to be using BrightScript at all. VS Code ships with this in the editor. You don't have to choose anything. But if you wanted to change what language server version you're using, that's directly linked to the BrightScript version. So we're going to go ahead and change the installed version to 0.68.5. which was the last release before the language server rewrite. And I want to show you some of the performance issues that we had in here that I will then show you the fixes for that we've made. So just to make this a little bit easier to understand, I've got a little test project here with 20 XML files, and this produces 20 scopes, plus the source scope makes 21 scopes. And these buttons don't do anything interesting, and so by itself, this project would validate pretty quickly. But I've added a BrightScript plugin here that basically burns a whole bunch of time to make the entire validation process slower. And that is just to simulate larger projects without actually showing any proprietary large projects, since there aren't many free open source projects that I could show in this presentation. So anytime we validate a scope, which will be each one of these, will spin for about 200 milliseconds. And then whenever we ask for semantic tokens, which is what's coloring some of these things green, we'll wait 3,000 milliseconds. So let's go ahead and I'm going to reload the window just to show you the rough amount of time it takes to validate the project. We're just waiting for the BrightScript language server to show up here. There we go. Okay, so it looks like the validation took about 4 seconds to run. And let's prove that's still the case. I'll just start typing a little bit more, and we can watch the logs down here go. There we go, about 4 seconds, which makes sense. We've got 200 milliseconds, 20 files, so about 4 seconds. So now if I wanted to get completions, like I want to do is string. That came up right away. Let's try it again in the middle of the validation. You'll notice that now it took the entire validation time. Let's do that again. Let's just get some of these going. And that took the whole time again. So this is one of the big challenges that we had with the old language server, is validation was so deeply ingrained in the system that you had to wait for the project to validate before we could answer questions like completions or hovers. And so in the language server rewrite, we have completely decoupled those. So let's go ahead and upgrade to the latest version of BrightScript, and I'll show you the difference. I'm just going to wait for this to finish spinning there. Okay, and we'll go back to the language server again. And here we go. Now notice we're starting to see some cancellation events in here. And the way we're able to do this is by breaking our validation cycle up into very small chunks. So rather than doing a for loop and validating every scope, we'll validate a scope, do a small sleep, to allow the Node.js event system to interrupt us if we wanted to stop it. So we pass a cancellation token around, and we're able to cancel validations as soon as a specific chunk of work is finished. So now let's just do our same test here. And there we go. That's coming back significantly faster. Remember I said that we had set our scope validations to about 200 milliseconds at a time? That's roughly what I'm feeling there, is we have to cancel the existing one, then we have to respond to the question and send it back. So I would guess about 230, 250 milliseconds latency, which is significantly better than the slowdown that we had before. In addition to all of the performance improvements, we've also added a little bit more useful logging and status detection for what's actually happening. So remember back in my plugin how I had added a 3-second spin wait on semantic tokens. Doesn't even really matter what that functionally does. So just know that one of the actions is going to take 3 seconds. So let's type a little bit and hover down here. And notice that get semantic tokens event is still in that list. So if you end up in a situation where something in the language server is taking a while, you should be able to hover over the BrightScript version at the bottom here and figure out what items are taking so long. So this could be really helpful to us as developers and maintainers of these tools, because we can have an idea of what is actually bogging down your system. And you notice that they update as you hover over them, and so you can hover over this and it will show you in real time as the values change. See, they're going up and down. There we go. So hopefully that's helpful. There is one more feature that I want to show you though. If you open up settings.json here, as I mentioned, we did a full rewrite to the language server. We also added the ability to multi-thread the project. So historically, whenever it would validate projects, let's say you've got a base module and 2 submodules, and each one of them are Roku projects that the language server can validate, it would run them sequentially. So do base first until it was done validating, then validate submodule 1, then validate submodule 2. But with this rewrite, we've added the ability to run all of the projects in parallel, each in their own thread. So if you do BrightScript.languageServer.enable threading, which this is by default. So this is more if you needed to turn it off. What's going to happen is it's going to spin up a Node.js worker thread for each project. And the language server serves as the interface in front of them and will communicate to each of the threads in parallel. So that means all of your projects should validate way faster as long as you've got enough cores to serve all of those. It only uses 1 core per project. And we've seen a significant increase in throughput using this. But if you have any trouble, you can always turn it off and see if that is causing the problem. And our last point here in the VS Code extension updates section is this scene graph inspector. We've made significant improvements to this tool, and I want to kind of go over some of the benefits of this new way of doing things. So if you're not familiar, the scene graph inspector is similar to the Google Chrome developer tools. And so I'm going to go ahead and expand this, and you can see here are all the different nodes on in my application. And I can expand those. And it works kind of like Rail in that you can get information about specific nodes. And we can pair this with the Roku device view, which is down here. I'm going to go ahead and move this over to the side so that way we can have it just a little bit larger. And the Roku device view is taking a screenshot from the Roku device as fast as it will feed it. Generally, it comes out to like every 900 milliseconds to every second and a half. But this is live from my device. So you can click this button right here called Inspect Nodes, and as you move your mouse around, it'll start to show you the node that's under your cursor. And one of the nice improvements we've made is if you notice at the bottom right here, it's going to disappear when I move my mouse. But we used to only be able to show you the closest thing to your cursor. But what happens if you've got a parent that has a child and your cursor's in all of them? So we've added the ability to move the arrow buttons to go left and right, up and down, to navigate through all of the hierarchy of elements. So that is a child of something, which is a child of that, which is a child of that, which is a child of that, and it just keeps going and going and going the whole way up to the top of the scene. This is a great improvement because before you wouldn't be able to get to some of those parent containers as nicely. So let's go back here, and as you notice, as I'm clicking around, it's actually selecting the element, and as I highlight around again, let me go back, it's going to focus the element that I've hovered over. The way that this scene graph inspector and the inspect nodes features work is when you sideload your application, we actually inject a small utility library along with it. Now this is opt-in, it doesn't happen out of the box, but what happens is whenever the application is running, not paused at a breakpoint, we're able to send requests to the device to ask it questions to our service that's running on there. I think it's running over a socket, and so we'll send a request like, send me all of the nodes in the entire tree. And then that's what we use to build this. That also powers the entire list of items over here as you're inspecting around. Now, there were definitely some edge cases that made it really difficult to implement efficiently. And sometimes on a larger application, that could potentially take up to 800 milliseconds or even beyond. And so what we've done now is Roku provides a feature called App UI. And so it's an ECP query right here. And whenever your application is running, you can hit this route and get the entire scene and all of its children, all of the nodes as XML. Now this comes with some of its own problems. It wasn't just a quick swap replacement, but by doing this, by the way, only takes about 200 milliseconds. It's significantly faster. By doing this, we're able to refresh the data much more frequently. So now this tree view will refresh, I think it's once every second. We may have added a flag or a setting to change that. But if you don't want it to be running, you can click this pause button for screenshot capture pausing. We also have a play pause button here to resume this refreshing on that 1 second interval. Now, this basically has the same constraints as the previous implementation where it only works when the application is running. If you're stopped at a breakpoint, all of this functionality kind of freezes. But we believe we have full feature parity between the old implementation and the new one, as well as some enhanced functionality like I've explained before with the ability to kind of click through all of the different parents there. So ideally, this will be a drop-in replacement. Unfortunately, we don't have a way to run both of them at the same time. So this has been released, and we're optimistic that it won't break anything if you're used to using it. But please let us know if we've introduced any issues. Another cool feature of the Scene Graph Inspector is that it has the ability to track the focused scene graph node and automatically focus that item in the inspector tree. So you see here that I'm navigating through focus on the device. And if I double click this button right here, we're now in track mode. And so as I go up and down, I'm just using my remote. I'm not touching my mouse or keyboard at all. It's changing focus inside of the Scene Graph Inspector tree. So this can be super handy if you're trying to figure out focus issues or even just understand what item is focused, but keep track of that on a regular basis. And one final thing I want to mention about the Scene Graph Inspector, and specifically the App UI implementation that we're showing you here today, is that we have been able to solve a long-running bug that's been there for a while. Array grids don't give us direct access to their children. So like row lists is an example. Those item components, we can't directly figure out what their parents are. So I just want to show you a screenshot here of the old version prior to these updates. And you'll see there's this rogue row list item component right there. That was the best place we could figure out where to put it because certain items just, we don't know what their parent actually is, or maybe Roku internally is moving them. And so in our new implementation, those elements, this is a live application now, those elements are correctly hidden inside of their children because App UI knows where they're supposed to be. So this is a great benefit of App UI, and it can help kind of remove some of the quirks in this system. And that's it for most of the editor-related features in the VS Code extension. And now I want to transition to talking about the debugger enhancements that we've made. Most of these are still going to be inside of VS Code, but they are all related to debugging. So the first item we're going to look at is the BrightScript debug protocol. Roku introduced the debug protocol several years ago at this point, and we've been collaborating with Roku to add new features, fix bugs as we discover them. Historically, the VS Code extension has used the Telnet connection to power its debugger, which involves scraping every single Telnet output line to try to figure out what's happening. Now, this can get quite brittle at times, and it's pretty easy for the extension to get confused or lost. The debug protocol solves this problem by providing a consistent API to support all of the various requests that a modern debugger needs to run. And you can scan through this if you want. It's a binary protocol. We've implemented the entire thing in VS Code, so you most likely don't need to re-implement it yourself. We provide that available inside of the Roku debug module, which you can find here on our GitHub page, and you can also install it through NPM. Back in November of 2023, we ran an experiment where we enabled the debug protocol by default. But we had to roll it back due to some issues that users were encountering with the user experience. And mostly these issues were on the VS Code extension side. And so we took some time, we resolved all of those issues, and back in February of this year, we were able to enable the debug protocol by default. And since the rollout, we haven't really been made aware of any issues. At this point, I think we're fairly certain that the debug protocol is stable, and it's going to be the default debugger moving forward. Now, that doesn't mean that the Telnet debugger is gone forever. It just means that we're going to spend a lot less time trying to fix bugs in the Telnet debugger because we need to invest that valuable time in making the debug protocol the best that it can be, especially considering how much more powerful it is and how much more consistent and dependable and predictable it is. And just one more thing before we move on to the next point, I want to quickly show you how you can enable or disable the debug protocol using your launch.json. So as I mentioned before, it is set to enabled by default. And so when you autocomplete that, it'll come in as true. But if you switch this to false, it will then say that all of your debugging sessions will use the Telnet connection instead of using the debug protocol. And you can set this here in launch.json, or if you need to change it globally, you can change that in your user settings as well. And so you can do that like right here. You can set that to true or false, and that will apply globally, but will then be overridden if you have the value in here. The next point we're going to talk about are improvements that we've made to the output logs. We've introduced a new feature that will rewrite the device paths in your console output so that they point to the actual files in your project. So let's go ahead and turn that on and show you a quick example. This new property is called rewrite device paths and logs. It defaults to true, but you can always turn it off. So let's go ahead and turn it off so you can see the normal logs. We'll do a new demo project here. Let's look at the output. So here's a good example. It says thread selected, and then we have a package path that points to main.brs. And notice that is obviously not clickable. It doesn't go anywhere. So let's run this again, but turn this flag to true. And this time, we've rewritten those logs to point to the actual file. And now I can control click it, and it takes us directly to that file. Another improvement we've made to the output logs is that we better handle ANSI colorization. And here's a really great example of that. In the Rooibosch unit test framework, we recently added the ability to colorize the output. This is using the Mocha reporter that we added last year sometime, and it wraps all of the success and failure messages with ANSI colorization. And so you can check this code out if you're interested in seeing how we do this on device. But let's look at what this looks like in practice. So in the VS config for Rooibosch, we're going to set colorize output to true. We're going to set the reporter to Mocha. And this is just to show you some colorized output. Our console supports those colors no matter what application is providing them. Run this, and then we are going to open up the output panel, and you can see right here that we have red and green text, which indicates that a unit test is succeeding or failing. And we support all of the ANSI color decorators that a normal console would support. And for some of the output consoles that don't support those characters, we're able to strip them out so that your logs are still readable without needing to enable or disable the colors all the time. Next up, we've added a few new features to the REPL that provide real-time property name completions as you type. So go ahead and take a quick look at an example of this. This is the standard with task project that I've used in many of my demos. Let's go ahead and add a breakpoint here on 18 and go ahead and launch. So what's going to happen is that here in the debug console, whenever we hit this breakpoint, we're going to start to see completions as we type based on the known interfaces that your variable implements, as well as any properties that may already be available on it. So let's go ahead and type m dot. If you see here, here's a bunch of my historic completions, as well as all of the methods that are available on m because it's an associative array, as well as port. And we can ignore this one. This is just a property that is set during the Roku device view and scene graph inspector features that I showed earlier. So let's go ahead and type one of these variables here, port, and it's completing port because it knows that property actually exists. So let's add another one, m.new var equals hello. Now if I do m.new, we get a completion there for that variable as well. So this is updating in real time. As you're typing, we're sending a request to the device to figure out all of the properties that are available on that, as well as we're running BrightScript behind the scenes to figure out what the type of the object is, to then go look up all of the properties on the interfaces that it implements. So now let's take a look at virtual variables. For the past few years, we've only really introduced one or two virtual variables like array length or scene graph node parent properties. The way they work is by running code on device for each of the virtual variables. And the problem with them is that as you expand more and more variables, your stepping speed starts to drastically slow down because we're running more and more code to evaluate those variables every time you step. To mitigate this, we've actually converted many of the more expensive variables into virtual properties, which will only be evaluated after you expand them. And because these variables can be evaluated on demand, meaning only when you actually click on them or expand them, we were able to add a significant amount of new virtual variables. And here's the pull request that introduced all of these virtual variables. Let's take a quick look at the list. We're not going to get too in depth here, but just to give you an idea, almost every single interface that every object on Roku devices implement are here. We've added all of them, and it goes through and it adds each of the virtual variables for each of those. things like metadata, which corresponds to the .get metadata function, or thumbnail, which is .get thumbnail. And again, all of this code runs only on demand. So let's take a quick look at an example. We're going to use the standard with task project. And let's go ahead and put a breakpoint right here. Okay, so now the section variable is a row registry section. And if you notice here, these $key lists and $contents are virtual variables. When I click this, you're not going to be able to see it. It's going to go pretty quick, but click, and then it had to evaluate that, and here's the value. You can do the same thing. There's a bunch of these on scene, like local bounding rect, and scene bounding rect, HTTP agent. So some of these are coming down really quick, but it's only going to evaluate them when we need them, which makes stepping speed significantly faster. So in addition to these virtual variables that we've added as part of our VSCode extension, Roku also recently added support for virtual variables directly through the debug protocol. And the way we've architected this is anytime Roku sends us a virtual variable that they support, we're not going to add our on-demand run code logic because they're officially supported variables. Here's another example here. So parent, let's see if we can find that. Parent right here, that property is coming directly from Roku. So let's go ahead and go out to one of our components. We'll go to like main scene or maybe one of these, like a list item. And let's resume. And then we'll just see if this thing's loading. And there we go. So now if I do m.top.$parent, this is coming directly from the Roku device, and we don't need to evaluate this on device by running custom code to look up what the parent is. And you can just keep digging into these and digging into these. So parent will be there again, and it'll just keep going and going and going. Another great feature that Roku added to the debug protocol this year is exception breakpoints. And this allows you to configure what types of exceptions you want to break on, either caught, uncaught, or both. Now, you need the debug protocol to be enabled for this to work. This does not work on Telnet. And then let's go to the debug tab. And by default, we're only going to break on uncaught exceptions. But you can also stop on caught by doing this, or you can turn them both on or off. So let's add some code here. Okay, and let's run this. This is the standard configuration, and then I'll show you what the caught exceptions does in a minute. Okay, so we threw an exception, and it's stopping on uncaught. Now let's turn on the caught exceptions as well and run this again. And this time we should actually stop right before the try kind of eats the exception. And now if we resume, it'll keep going and then eventually stop on the uncaught. So this is really powerful for when you have maybe some code that has been kind of battle hardened to make sure that the application will never crash, but it might be catching an exception that you weren't expecting it to catch, so it's hard to narrow down exactly why something is failing. So by turning this on, you might end up with a lot more exceptions, but it'll help you find exactly where in your code those exceptions are being caught. Another great feature that we added this year is the registry scope. So the way you get to that is just by debugging normally. So let's go ahead and sideload our application. And then we're going to open up the variables panel here. And once we've hit this breakpoint, you're used to your local variables being up here that you can expand, but we also have registry now. So we can open up, we can see sections, and notice how I'm writing alpha and beta with their values. Those are all inspectable here. Now, the one caveat is that your device does need to be signed in order for this to work, but you get a nice warning message there saying that your device is not signed. So it's easy to understand why it may or may not be working. Now, I know earlier I mentioned that the debug protocol is now the default way of doing debug sessions, but for those of you that are still using Telnet for some reason, we did add a new feature that kind of helps improve the stepping speed. So let me give you an example of how that works. Let's go ahead and open our launch JSON, and we're going to set enable debug protocol to false, so that way we're using the telnet debugger. And then we're going to set another property called defer scope loading to true. And set a breakpoint in here and start. Now, what this does is, as you recall, with the telnet debugger, everything we do has to be scraped from the telnet connection. And what that means is every time you step, every local variable needs to be looked up, which can make it pretty slow to debug. And now if you notice over here, the local panel is actually collapsed by default. And that's what that property does. It says, don't load the local variables until we actually expand it. So I'm going to do that. You're going to watch it spin a little bit. Now I step, and we're going to watch it spin again. You can see the little spinner just show up for just a moment. But then if I collapse it again, notice how much faster the stepping is. This can significantly improve your telnet debugging for those of you that are stuck on the telnet debugger, but hopefully most of you can move to use the debug protocol because it's going to be a lot more stable. Okay, so our final point here in the debugger enhancements category are telnet and protocol stability fixes. I don't have a lot to show here, but we made a lot of under the hood improvements to its stability. There were issues where sometimes you would start a debug session and it works. You would stop and you'd start again, and then it would just time out. And then you'd run it again and it would work. So there were some issues with how we were cleaning up our socket connections to the device, as well as properly handling certain edge cases. So those have all been cleaned up, but there is one thing I want to show you that we've been trying to fix for years, and I think we finally figured it out. And that feature is this restart button right here. For some teams, it would always work, and other teams, it would never work, and some people would have mixed results when using it. And so all of the stability fixes that we added in to clean up when we're shutting down and properly wait for sessions to end before we start again has made this button work. So now when you click it, it should actually just work. And there we go. For our final topic today, I want to spend some time talking about CI/CD and Roku. Now, Roku doesn't have an automated way of deploying their applications to the store. So the context of these discussions are going to be focused mostly on how we can sideload zips in a continuous integration environment like GitHub Actions in order to run unit tests or validate certain things, maybe automation testing, for example. So let's go ahead and get into an example here. I'm going to show you how to install the self-hosted runner, how to link up a Roku device to that, and then also how we can run some unit tests using GitHub Actions. So let's go ahead and navigate to the RokuCommunity GitHub organization. You're obviously going to need to navigate to your own GitHub organization and have administrator rights to be able to set this up. So we'll go to Settings. We're going to go down here to Actions and then choose Runners. From here, we want to choose New Runner, a new self-hosted runner. And you can see I already have a few runners here. We're going to be creating a new one for this demo. Now we'll choose Linux, and x64 architecture works great. Okay, I'm going to go ahead and copy these instructions. Now, if you wanted to run multiple runners on one device, you would just need to change the name of the folder. But we're just going to do the one. So we're going to run that. And then we'll do this. Okay. We'll just validate that everything's good. Then we're going to extract it. Okay. And just full disclosure here, this token is only valid for about an hour, so no need to worry. We are not leaking tokens in this demo. Let's go ahead and configure the runner. All right. Okay. And the runner group can go to the defaults. We're going to use the name Mac Mini 1 for this runner. And then I'm going to add Mac Mini as a label in addition to self-hosted. That way we can target this specific runner. Okay, everything's set up and going. Now there's one more thing we want to do. It is highly advised to assign a static IP address to your Roku, because you don't want to have 2 or 3 GitHub Actions runners all trying to use the same Roku. You could have runner 1 spin up and then use the Roku. Runner 2 spins up before number 1 is done, and all of a sudden runner 1 fails because somebody else took over the Roku. So we advise setting up for every single Actions runner that you make, you should have a dedicated Roku with a static IP address. So that way you can always talk directly to that Roku. So what we're going to do here is we're going to look at the .env file, and we're going to add just a couple things here. I'm going to paste those. And so this is the IP address that I've statically assigned on my router for that Roku by MAC address, and then my developer password for that. Okay, now that I've configured that, those environment variables will be available to actions that run with this specific runner. So let's go ahead and run it. Here we go. And it's listening for jobs. So let's go make sure that's actually the case. And here we go. Here is my new runner. It's configured, a Mac Mini. So let's now go and move on to a sample project where we can actually target this runner. This is a sample project from the Rooibush unit testing framework. Rooibush is a fairly popular unit testing framework in the Roku ecosystem. And so what I'm going to do with this project is show you how to set up and configure GitHub self-hosted Actions runners, and then be able to run our unit tests on the Roku device that we just assigned it to a moment ago. So let's just take a quick look here. Go into GitHub, and ci.yaml is already set up. And this is running on the latest version of Ubuntu. So this is running on a GitHub runner, a cloud runner. And we set up Node, and we check out the code. We install the Node modules, and then we build the tests. And so this is nice for validating that we don't have any compile errors using the BrightScript compiler and the Rooibush unit test compiler. But we want to actually run the unit tests on device. So remember earlier that we had configured the Roku host and Roku password environment variables. So Rooibush ships with its own CLI. So let's do run tests on device. This is a new script we're going to make. npx Rooibush. And we're going to do host. And we're going to do $Roku host password $Roku password. And those need to line up and align with the environment variables we set in the .env a moment ago. Great, so we've got our script. Now let's change our YAML to run this. Run that. Okay, so one more step here. We don't want to run on Ubuntu latest anymore. We want to run on self-hosted. And just for the sake of this demo, I want to run it on the Mac Mini. And so what it's going to do is it's going to do that it has to resolve all of these. So it will find all of our self-hosted runners. Then it will pick one that also has the Mac Mini label. Let's go ahead and commit that. And we're going to go ahead and push that. And because I have this set up that it builds every time we push to master as well as pull requests, the build should start almost right away. We're going to go out here. We're going to refresh. And there we go. There's my commit directly to master. And it's running. So let's take a look at what's happening here. So it's currently setting up Node. Now it's going to install the Node modules. There we go. All the Node modules are installed. Now it's going to start building the tests. And that again is still running in Node land. We haven't actually run against the device yet. So now we're running the command against the device. And it's going to do a little bit of compilation to get the unit tests ready to go. And there we go. So these are Roku logs. You see those there? Those should look familiar to you. And it passed. Now, what's nice is, if you wanted it to fail, the Rooibush CLI will return a non-zero error code, a status code, when it fails. And so if we got something that was a crashed or a failed, it would return, I think it's 1. And so that will also fail the CI job. Now, one bonus tip for you is starting in Roku OS 15.0, they've added the ability to actually reboot your Roku and check for updates from web. And so you can go to this website right here, plug in SWUP with an underscore on your 15.0 or greater device, and you can click check for update. I'm going to go ahead and show my Roku actually when I click that. And you can see it's checking for updates. And the same thing for reboot. I'm going to go ahead and click that. And there's going to be less to see here, obviously, because it's rebooting, but you should see the boot screen in just a moment. So yeah, this is a great benefit because it eliminates the need for your server admins to go in and use a Roku remote and find the right remote to check for updates on that one device that won't let you side load your zip because it hasn't checked for updates in a while. So both of these features should essentially eliminate the need to go in and interact with those Rokus at any point. So hopefully that's enough information to get you started with using self-hosted GitHub Actions runners. They're really powerful, and honestly, they're probably one of the only ways to really run proper on-device testing. And that's it. Thanks so much for taking the time to listen. I know I threw a lot of information at you. We've been hard at work this whole year working on these features, and there's not a ton of us working on RokuCommunity features. I'm the only one that's really full-time working on this, and then most of the rest of the contributions come from community members whenever they're able to fit it into their schedules. So with that, I just wanted to encourage you, if you've got a spare hour or two a week to contribute, that would go a long way for us. There's a lot to do. It's really hard to keep up with all of the backlog that we have. And so if you think you have any way to contribute, I am more than happy to meet with you to figure out a way to get you plugged in. It doesn't have to be these giant features. We have documentation that needs fixed. We have a significant amount of tech debt. So if that's something you're interested in, please check us out on our RokuCommunity.github.io site that I showed earlier. And yeah, that's about it. So let's go ahead and show that Q&A Slido QR code link again. If you have any questions about any of the topics that I covered, now's the time to submit them, last chance. And then we're going to get into our Q&A session in just a moment. I just want to say thanks again.
So we do have a question now that has been submitted. So we have a question from Kevin. So question about GitHub Actions. You mentioned that the token only lasts an hour. For a production system, how do you cycle tokens to keep your runners always live?
Yeah, I can speak to that one. So that token was an installation token. You use that so you don't have to enter a username and password when you're setting up the runner. But no, your GitHub Actions runner is just permanently connected. I think GitHub will like disconnect it if it hasn't seen it online in like a couple of days or a month or something. There's some kind of cutoff window. But yeah, those tokens were just for installation. You don't have to do anything. My runner's been running for months. You don't have to touch it at all.
And to clarify the one point that Bronley touched on, it's 30 days of inactivity on a runner, and then it'll get removed from the system and you'd have to re-add it. So if you have a bunch of runners, but one of them doesn't get hit in 30 days, you might need to re-add that.
Okay, awesome. Next question we've got, any tips or tricks for integrating the debugging protocol into an older or overly complicated code base? So spaghetti code, I guess.
So maybe you could ask a clarifying question if I don't hit this. I'm going to try. But so the debug protocol is you use it with any Roku app. And so you wouldn't have to do any code changes to your Roku app to make it work with the debug protocol. But what you might be asking is how to make the VS Code editor and the debugger in general understand your project structure so that you can sideload the application. And that we can definitely help you out if you just reach out to us on the RokuCommunity Slack with, like, hey, here's my project, here's the weird structure. How do I tell VS Code how to understand the project? We can definitely help you figure that out. And if that's not what you're asking, ask a follow-up question and let us know.
Okay, awesome. So we got a comment GitHub Runner is a huge win. No notes. Looking forward to using it heavily. Thank you so much for that. Yeah, any more questions? This is the Slido info. Go ahead and put it in.
I'll just mention I put it in Slack there for everyone. If you are having project setup issues, as Bronley was mentioning, you can join us in the VS Code BS language extension channel in our Slack community. That'd be the dedicated place to ask for questions.
Yeah, and if you're curious where to find the Slack community, you can go to RokuCommunity.github.io, and we have a direct link to be able to join up to our community Slack.
Mhm.
We're on there all the time, like constantly.
So if we don't have any other questions, then we're gonna wrap it up for the day. We will start tomorrow at 9:30 in the morning Pacific. And I got okay. Another question. Oh, another one. Okay, I think I missed this, but how did the IP routing work on that GitHub Actions runner getting to the private IP of the Roku?
Chris, you want to take this one?
Yeah, so generally, at least what we do, I'll use our setup as an example. We have about 8 runners in parallel. And one thing you can do is you can set up an env file essentially in your project where you install that runner. So if you have any scripts or anything like that, they can pull from that env file that would be dedicated for that installation. And for us, we hard code the IP of the Roku, the developer password for that Roku, etc. And that allows us to kind of change that without having any weird configurations external to the runner that it has to pull down. And GitHub, if you have multiple runners, it will actually take care of the pooling of all your different runners. So if you have 8 of them and 3 of them are used, it automatically takes care of sharing it around based on the labels you've configured.
And as I'm reading this again, I think there might be some confusion with how GitHub Action self-hosted runners work. The self-hosted part is kind of critical there. My Mac Mini is sitting on my desk right next to my actual Roku. They're both on the internal network. So your self-hosted runners are internal, and they just have a single connection out to GitHub and all their magic infrastructure. So you don't have to do any like internal routing or punching holes through your firewalls. Your runner's internal, your Roku's internal, and GitHub just asks the internal device to run through some kind of tunnel that they've set up. So yeah, all you have to do is give the IP address to the Roku, and it should all just magically work.
Okay, awesome. Next question we've got, have you seen any gotchas with GitHub runners on older devices like Littlefield or gotchas at all? And I think this is, of all the dev summits that I have been a part of, I have never had Littlefield mentioned more during Q&A than this dev summit. So yeah, any gotchas with devices like Littlefield?
Yeah, I don't think we've had any specific, at least like generational issues with runners. Usually, the most common issue that we run into, like even your own local development environment, is things like checking for updates or the device getting in a really weird state and you want to do a hard reset on it to like a reboot essentially, which both those things have been solved as Bronley had shown. Um, the only other gotchas potentially is if your runners are set up, if you're trying to use them for building PKGs and signed packages and such, but the Roku account you have it set up with is the same that people use to download competitor apps and do competitive analysis and such. Sometimes you can run into a bit of a memory problem where there's not enough flash on the device to do the packaging, things like that. So those are kind of like the 3 main ones we typically run into. And like I said, 2 of those have basically been solved. And the third can be solved by just putting them on a different account and using them strictly for your CI purposes. Don't mix them with your day-to-day use.
Okay.
I do think there was one in Zoom, basically asking about more info when you have an exception Is it possible to get more info of the exception when a breakpoint is reached? Is the question.
Yes. Yeah, that was I don't think I showed that. So when we implemented the exception breakpoints, there is like a secret variable. I think we have it in the autocomplete there. I can't remember the name of it off the top of my head. Is it underscore BRS underscore exception? I can't remember. But there is you do have access to the exception variable. And if you're using the debugger and you go to edit that breakpoint, you'll get that as kind of the tooltip or the autocomplete there. So you should be able to see what that variable is. Yeah, and you'll have full access to that. You can inspect it like a normal variable if you put it in the watch panel or the variables panel. Yeah, that's a great question.
We'll try to find that variable name and post it in the Slack as well, and make sure it's in our doc somewhere.
Okay. Any other questions before we wrap it up? Anybody?
Real-time follow-up here. The variable name is underscore underscore BRS underscore ERR underscore underscore. And that's not ours. That's coming from the protocol. I think they were looking to make sure they didn't conflict with anything on device. And so, but like I said, it shows up the moment you go to edit it. That's what's showing there by default.
All right. Thank you for providing that clarification. Okay. Well, we don't seem to have any more questions, so we're going to wrap it up for the day. Again, we'll kick off tomorrow at 9:30 in the morning Pacific, and we'll have more panels tomorrow. I don't have the schedule in front of me, but we will be ending the day with the RSG panel. And so for that panel, we are going to have many members from our engineering team. Please come ready with questions. Please think about RSG questions that you want, because that's going to be a packed panel with engineers from our side. And we definitely want to give you the opportunity to ask important engineering questions to our engineers directly. So, and I think that's it. Okay, thank you so much for everybody who's joined us so far today. We'll see you all tomorrow. Thank you, Bronley and Chris, for your time again, for sharing all of this with us every year. And that's it for today.
Thanks. See ya.
Thank you.
Hey.